Good morning friends, good morning students. In today's video, we'll discuss pre-nucleotide catabolism, right? So breakdown of nucleotides will lead to formation of final product that is uric acid, right? The normal levels of uric acid are in males 3 to 7 milligram percent and in females they are 2 to 6 milligram percent, right? And increased levels of uric acid will result in gout gout and there are two types of gout. One is primary gout and second is secondary gout, right? And there are also other disorders in which the levels of uric acid are increased. Second is Lesch-Nyhan syndrome and the third is severe combined immunodeficiency, right? And in there is a disorder in which the levels of uric acid are decreased, that is purine nucleotide phosphorylase deficiency. In this disorder, the levels of uric acid are decreased. In the earlier three disorders, first is gout, the levels are increased. In Leishman syndrome, the levels are increased. In SCIDS, the levels are increased, but in prenucleotide phosphorylase deficiency, the levels are decreased. Now we will start with catabolism proper. Now in catabolism, there are preens. There are basically two types, adenine and guanine, right? So breakdown starts at the level of adenosine monophosphate and guanine monophosphate. Now we have the principal molecules AMP and GMP that will finally degrade to form uric acid, right? So AMP during catabolism is first converted into IMP, right? By AMP deaminase, right? So now these three molecules will finally lead to the formation of uric acid, right? During breakdown, the first step requires the enzyme nucleotidase, right? And in all the three steps, we use water molecule and phosphate will come out, right? The enzyme is nucleotidase in all the three steps, and from AMP will get adenosine, right? From IMP will get, from GMP will get guanosine. We have guanosine, which can be further converted into guanine, right? And inosine can be further converted into hypoxanthine, right? And both these steps require the enzyme purine nucleotide phosphorylase, right? And these steps, in this step, there is a relation of ribose 1 phosphate, right? And from hypoxanthine will further form xanthin by enzyme xanthin oxidase, right? And hypoxanthin can be further converted into xanthin can be further converted into uric acid. That is the final product. The enzyme is again same, xanthin oxidase. In both these steps, we require water and oxygen, and they are converted into hydrogen peroxide. In the same manner here, water and oxygen, they will liberate to form hydrogen peroxide, and will get the final product, that is uric acid, right? And adenosine here can be converted into inosine by enzyme deaminase. So the final product is uric acid, right? This guanine can be converted into hypoxanthin as well. From hypoxanthin, it is finally treated as uric acid. So this enzyme, xanthin oxidase, is a metallo-flavoprotein, and it contains molybdenum, FAD, and iron, right? Now the first disorder of this metabolism is gout. If the levels increase above 7 milligram percent, it will lead to hyperuricemia and gout. The primary drug of choice is allopurinol, right? It has two mechanism of action. One is by competitive inhibition, and second is by suicide inhibition, right? Now the second disorder is Leishman syndrome. In this disorder, there is also hyperuricemia, but there are other characteristic features like there is mental retardation is there, right? And the patient exhibits symptoms of self-mutilation, and there is aggressive behavior, and very low IQ levels. And now the third disorder is severe combined immunodeficiency. There is ADA deficiency. Deficiency of the enzyme adenosine deaminase, and there is combined E and B cell dysfunction, right? So there will be accumulation of deoxyadenosine triphosphate, and this will lead to inhibition of enzyme ribonucleotide reductase, right? So when this enzyme is inhibited, the DNA synthesis will stop and will finally manifest the symptoms of this disorder, right? Now we will start with the fourth disorder, that is purine nucleotide phosphorylase deficiency. In this disorder, the levels of uric acid are less, and there is defect in T cell function only. The B cell function is normal, but only there is defect in T cell function because there is combination of deoxy GTPs, but the B cell function goes on normal. There is only defect in T cell function. So please like the channel and subscribe the channel. Please share with your family and friends. God bless. Thank you.